What's up, guys? It's Dan from SageMathTutoring.com, and here's a video where I'm helping a seventh grade student of mine with worksheets and stuff and homework and stuff. This has to do with percentages and fractions, okay, and some other things. So let's start. So obviously, they're going to give you a nice sort of summary of what they want you to do, but the bottom line is you definitely need to know the definition. A percent is a ratio or comparison of a quantity to 100. And what they're saying here is if you have a fraction, you want to turn that fraction into some other fraction, maybe, that has 100 in the denominator. And then once you've done that, whatever the numerator is in that moment is going to be your percentage. Now, the only exception to what I just said is if you have a fraction that already has 100 in the denominator. And then all you need to do is just pay attention to the numerator, and that would be the percentage. So they outline three separate sort of scenarios that you have to deal with. Um, let's say you start with a fraction that's 3/10. Well, that's not 100 down there, so you have to multiply 10 by something that would result in that being 100 down there. So in order to do that, you multiply the 10 times another 10, because 10 times 10 is 100, as you can see here. And then we also, you're not allowed to just multiply the bottom by 10. You would also have to multiply the top by 10 if you're going to do that. And that becomes 30 over 100. And of course, that's 30%. They also outline what happens if you have a number larger than 100 and a multiple of 100. Well, this is 1,000. So in order to turn that into 100, you have to divide it by 10, which is exactly what they did. And that's how you got 100. And you're not allowed to just divide the bottom by 10. You also have to divide the top by 10, and then you're going to have 100 down here, and you end up with 2.5, which is kind of a weird number, but you have 2.5 over 100. And once again, once you have a fraction where the denominator is 100, you're actually ready to just focus only on the numerator, and that would be your percentage. Okay, so the final example they give is when a second term of ratio is a factor of 100, a factor of 100. So they're using 20 because 20 times 5 is 100. They could have also used let's see, 50, right? Because 50 times 2 is 100. So this is just an example of a factor of 100. And then they said to themselves, okay, well, how are we going to turn this denominator into 100? And all you have to do is multiply 20 times 5 to do that. And of course, you can't just multiply the bottom by 5. You have to multiply the top by 5 as well. You end up with 45 over 100, which is 45%. And that's how you do it. So let's take a look at this right here. So this is 1, 2, 3, 4, 5, 6. That's going to be 6 out of 10. So it looks like these problems want you to just find the fraction first, actually. Okay, so that's what we're doing. We're finding the fraction first. So that's 6 out of 10. And 6/10. And we're going to have to multiply that bottom by 10 in order to get 100. That's the same thing as the above example, the first example. And that becomes 100 down here, and then we're going to have 60 up top. And as we said before, once you have 100 down here, all you have to do is pay attention to the numerator, and there it is, and that's going to be 60%. All right, now this next one's kind of interesting. It's 10 out of 10. Okay, you can clearly see it's 10 out of 10. And we have a 10 down here. We're going to want to turn that into 100. So similarly, we're going to have to multiply it by 10, just like we did in the last example, actually. Now we have to do that to the top as well. And then we end up with, over here, we end up with 100 down below and 100 up top. And as we had mentioned before, it's really the numerator that matters, and that's going to end up becoming 100%. All right. Now they're sort of highlighting the relationship between ratios and fractions. This is read as 1 to 10. You could also think of it as 1 out of 10. And this is 1 over 10, which is the same thing. Okay, so you could treat this number on the left as the numerator, this number on the right as the denominator. And they give you an example. So this is going to be 4 out of 10. So I would strongly advise write the fraction first and then go through the exact same process that we've been doing, where at the end of the day, we're going to be turning that denominator into 100. and paying attention at that point to the numerator. Do a little divider here. So this is going to be 12 over 10. So that's an improper fraction, but don't be thrown off by that. It's the exact same process. We want 100 down below, don't we? We want 100 down below. So we're going to get 100. We're going to have 120 up top. And paying attention to only that, and that gives you 120%. So that is possible. This is their way of saying every now and then you're going to get a percentage that's over 100. Okay, so that's 120%. But notice how the exact methodology that we used is the exact same. All right, that's the important part. Now we have 87 over 10, same process. Same process because we want this denominator to be 100. 870. Notice how easy it is to multiply any number by 10. It's going to be the same number, only with a 0 tacked on. So it's 87 with another 0, which is just 870. Now, obviously, we're focusing on the numerator at this point, and that becomes 870%. Weird percentage, but it is a percentage. They're kind enough to give us the fraction already. We don't have to do any that extra step of converting a ratio to a fraction. We already have a fraction. Now, I understand this is weird because there's a decimal here, but you don't want to get thrown off by that. Same process. Same process. This ends up being 100 down below. Now, here's the question. What is 10 times 0.1? Now, 10, whenever you multiply 10 times something, I know I said you're just tacking a 0 onto it. In fact, I just said that, right? I just said, oh, when you multiply something by 10, like 87, you just keep the 87 and tack a 0 onto it. Now, there is another way of looking at that, just for the record. The other way of looking at it is to say that, okay, 87, when you multiply 87 times 10, you could say you're adding a 0 to it, but another way, perhaps a better way of thinking about it, is that you're moving the decimal place over once to the right. So if you have 87, it's really 87.0. Okay. My student at home should understand that 87, it's really 87.0. And when you multiply it by 10, what happens? You move that decimal place over once to the right. So that becomes 870 after moving the decimal over once to the right. Now the decimal is right there. In fact, I'm going to draw it. Okay. That's what you do when you multiply a number times 10. When you multiply any number in the universe times 10, you're taking the decimal from where it already is and you're moving it over once to the right. Okay, so make sure that's clear. And that is exactly what we're going to do here. So we're going to take this decimal, move it once to the right, and that would give us 1. Once again, paying attention to the numerator, that would give us 1%. Boom, crushing it. Same deal with this. I believe my student at home probably is already getting the hang of this. 100, that becomes 9 because we moved the decimal place once to the right. Clearly the answer is 9%. And for the exact same reason, this one's going to be 15%. I'm not even going to do it because I think my student can do that at home. In fact, I want my student to try this and verify it. For the exact same reason, this is going to be 92%. All right, so pause the video if need be, dear student at home, and work on that, verify it, etc. Okay, now we're getting into the big leagues because finally we're being presented with something that is a little different. And the good news is it was covered up above, but the bottom line is the principle is the same. We just want this denominator to be 100. Now, what do we have to do to turn this denominator into 100? Well, we have to divide it by 10. Okay, we're going to divide it by 10 because what does dividing by 10 do? Dividing by 10 takes the decimal and moves it once to the left, and that would turn it into 100.0. So that becomes That becomes 100. I'm not going to write 100.0 because 100.0 is just 100. And then similarly, dividing 30 by 10, well, you could do that in your head. 30 divided by 10 is 3. Or you could think of it as the fact that, oh, the decimal's moving once to the left, and therefore it's 3, right? So then we have this, and then we have 3%. Unbelievable. Okay, then there's this one. 80 over 1,000. I'm going to do this one. I think I'm going to ask my student to try the other one on his own, but I will give the answer to the other one. So we're doing the same thing. We want this to be 100, so we're dividing it by 10, and then as a result, we end up with 100 down below, and the decimal moves once to the left. That turns the 80 into an 8, focusing once again on the numerator, and then all of a sudden we have the answer, also known as 8%. Boom. Okay, for the exact same reason, this one is going to be 3.2%. Verify that at home if you want to. And for the exact same reason, this one is going to be 8.6%. So that is the first page to these worksheets. All right. So hopefully all that makes sense. I have 2 more pages like this to get through, but hopefully all that makes sense. Okay. So what they want is for us to rename each ratio as a percent. That's fine. I mean, in a way, it's just what we've been doing. So let's take a look. So as I said before, these ratios could be rewritten as fractions, and in this case, it would be 1/4. Now, 4 happens to be a factor of 100. So what we have to do is we have to multiply 4 times whatever number you have to make the denominator 100. Well, that would be multiplying by 25. Now, you have to do it to the top as well, of course. And then we end up with 100 down below, and we have 25 up there. And then guess what? Focusing on the numerator would give us 25%. Okay, and that's the answer. Okay, so I haven't been boxing the answers, but just know that that's the answer right there. It's not this green thing, it's that. In fact, maybe I'll stop doing the green thing just so you can focus a little bit more on that thing. All right, now we have 3 over 2, same deal. It's like 3 over 2. Well, 2 times what gives us 100? Well, if you can remember, that would be 2 times 50. You have to do it to the top as well. Don't ever forget to do it to the top as well. We're going to have 75 up there, and then we're going to therefore have 75% because we are once again focusing on the numerator after having gone through this process. Okay, dokie. Then we have 9 over 5. 5 times what gives you 100? 5 times 20 gives you 100. And then we end up with 100. What's 9 times 20? 9 times 20, if you were to work that out, would be 180. And that therefore is 180%. Fantastic. Okay, now they're being smart with us by instead of having a colon, they're using this word 2. But I want you to understand that 2 really is the same thing as the colon. So this is the exact same process. Okay, so that's going to be 3 over 50. And 50 times 2 would give us 100. So we have to multiply not just the bottom, but also the top by 2. Then we end up with 100. And then we have a 6 on top, focusing only on the numerator. We end up with 6%. This one, for the exact same reason, I'm going to leave this up to my students. This one is going to turn out to be 16%. So pause and work on that, verify that. This one up here is going to be 68%. Verify that. Tricky one, but verify that one. Let me just make sure I'm right. Sometimes you got to be careful. Yes, I'm right. Okay, so that's that. This one over here is going to be 70%. But again, don't just take my word for it. The teacher would need to see work there. I'm sure the teacher would need to see work, so you need to try those for sure. Okay, so verifying all these if you have to. Let's look down here. Same principle, just multiply that by whatever you have to get 100 down there. Obviously, notice how your multiplication tables need to be fairly on point, right? I just knew that 5 times 20 is 100. Why? Because I've memorized that. So, unfortunately, you do need to have your multiplication table game on point. This is a weird situation. So we have 1.2 times 20. It's not times 10, right? Before we had a decimal times 10, and then we're like, oh, just move the decimal place once to the right. Well, you know what? This is a little bit more tricky. We are going to have to go ahead and bust out the old multiplication stuff where it's going to be like, actually, I'll do 20 up top. You can almost treat it like it's 20 times 12, only, make the mental note that it's a decimal right there. So just going through the motions, 0 times 2 is just 0. 2 times 2 is just 4. Put that 0 there. Then we end up with 0 times 1. Well, that's just 0. And then we have 2 times 1, and that's 2. Add it all up, 0 plus 0, 4 plus 0, and 2. And then we have to take into account that there was one single decimal present, one single decimal place present. So that's going to be taking place over here. And then we're going to put the decimal right there. Okay. Once again, since there was one decimal place present, there's going to be a decimal movement there, and the decimal gets placed here. It used to be here, and then we moved it there because we wanted to match that. So we end up with 240. So we have 240, or 24, rather, I should say 24. 24 over 100. Once again, focusing on the numerator, that would give us 24%. So that is a fairly tricky one, but notice how the original principle, the big picture is the same. Just multiply the top and bottom by whatever you have to get 100 down there. We did have to go up to the side with this part, 20 times 1.2. It's really 20 times 12, which is 240, but then we have to move the decimal place over because there's one decimal place represented above. Okay, same deal with this. Now we're going to be multiplying the top and bottom by 25 this time. So I can already see that's going to be kind of annoying. But the bottom, well, that's definitely going to be a 100. But the question is, what is 3.4 times 25? So what I'm going to do is I like to ignore the decimals in the beginning, where I'm literally just going to write 3.4. I'm going to pretend that it's a 34. 34 times 25, and I'm going to pretend it's a 34, and I'm going to put the quote-unquote larger number over the smaller number, pretending it's a 34, and then go through the motions from there. We have 4 times 5, which is 20, and then 3 times 5, which is 15, plus 2, which is 17. We're going to have that magical 0 right there. Then we have 4 times 2, which is 8. Then we're going to have 3 times 2, which is 6. Then we're going to add, we have 15, carry the 1, we're going to have 8. So it's 850, except how many decimal places did we have? Well, we have 1, so we're going to be moving the decimal place over to this position, giving us 85. So therefore 85 is what goes here, and therefore the answer is 85%. 85%. Okay. This one I'm going to do as well. So we have times 5, we have times 5, and clearly the bottom is going to be 100. And then the question is, well, what is 6.3 times 5? I'm going to treat it like it's 63 times 5 in the beginning. 3 times 5 is 15, and then 6 times 5 is 30, plus 1 is 31. And then we have one decimal represented, so we're going to take this decimal and move it over, and then we're going to end up with an amazing 31.5. So that goes here, 31.5. Now that's kind of unusual. We have 31.5 over 100, but remember, you just follow the laws. It's going to be 31.5%. It's not often we get these percentages that feature decimals inside, but it can happen. We'll do this one too. So we have times 4 because we want that 100 down below. The question is, what is 85 times 4? 8.5 times 4. I'm going to temporarily imagine it's 85. 5 times 4 is 20. Carry the 2. 8 times 4 is 32 plus 2. Plus 2 is 34. We have one decimal place being moved over, so we're going to have one decimal place being moved over, and that's going to be 34.0, also known as 34, also known as 34%. 34 over 100 is also known as 34%. All right, so that is that one. Let's take a look at these crazy word problems. Okay, so let's look at this word problem. A theater company sells 43 out of 50 seats available in their next performance space. What percentage of seats have not been sold? So notice how they're asking how many or what percentage of seats have not been sold. So they tell you how many they do sell, 43 out of 50, but they don't tell you how many they don't sell. So you need to be on guard with these problems to get really clear about what they ask for in the final question. The truth is that if they sold 43 out of 50 seats, then 7 out of the 50 would be the amount of seats that they have not sold. And if you want the percentage of that, you just pretty much go through the same motions that we've been doing. So it's really going to be 7 over 50. You ask yourself, okay, 50 times what gives me 100? 50 times 2 gives me 100. Not only do I multiply the bottom by 2, but I also have to multiply the top by 2. So I have 14 over 100, and that turns out to be 14%. Okay, so let's dive into this one. Your friend has a bag of 20 marbles. 7 are blue, 4 are red, 2 are green, and 3 are yellow. If the rest are white, what percentage of the marbles are white? Well, let's figure out how many numbers of marbles have been taken into account already. We have 7 blue, so that's 7 so far. 4 are red, so that's 7 plus 4, which is 11 so far. 2 are green, so that's 11 plus 2, that's 13 so far. 3 are yellow, so that's 13 plus 3, that's 16 so far. And then they say the rest are white. Well, we already have counted 16 total marbles, and the rest would be 4 marbles because there's 20 total marbles. So really, what we're doing is we're analyzing the fraction of 4 out of 20. Okay, 4 out of 20. And as usual, we're going to ask ourselves, okay, 20 times what would give us 100? Well, at home, I'm sure you know, 20 times 5 would do that. Now I have to multiply the top by 5 as well. So then I end up with 100 down below, which was the plan, and then 20 up top. And then that right there is the percentage. 20% is the answer to that one. So looking at number 30, 100 people in a supermarket survey were asked what kind of pet they own. 47 people surveyed have only cats, 33 have only dogs, and 7 have only an other kind of pet. If no one surveyed has more than one kind of pet, what percent of the people surveyed do not own a pet? Well, this is kind of an interesting one. So they tell you that 47 people have only cats, 33 have only dogs, and 7 have only an other kind of pet. So 47 people plus 33 people, that's 90 people, plus 7, that's going to be 97. And that leaves 3 people that haven't been accounted for. So that's 3 people out of 100 that don't own a pet. So we have 3 out of 100. Now, it turns out that this is already 100, so we don't have to convert it to 100, which means we're actually already ready to find the percentage. And the percentage in this case is 3%, because it was already a fraction that had 100 in the denominator. So that one turned out to be relatively easy once you sort of understood what was happening. They tell you 47 people have blah, 33 have whatever, and 7 have whatever. That leaves 3 left over. And how do I know they have 3 left over? Well, because there's 100 total people. Okay, out of 1,000 teens surveyed about next summer vacation, 362 said they will stay at home, 218 will go to summer camp, and 195 will go on a family vacation. What percent of students do not fit into the three categories? So that's very similar to this one, where they give you the total amount of people, and then they give you a few numbers of people that fit into various categories. But then there's going to be a certain amount left over, and that's the amount that you have to analyze. So first, let's just add 362 plus 218 plus 195. That is 775. 775. So I'll just write that. That's how many people have already been taken into account after adding 362 plus 218 plus 195. So then we want to know what percent of students do not fit into the three categories. Well, let's find out how many actual students don't fit into the three categories. And you would do that by taking 1,000 and subtracting 775. And in doing so, you would quickly realize that the difference is 225. So then it's 225 out of 1,000, 225 out of 1,000. So I'm going to write that 225 out of 1,000. Now we want to know what percentage of the total, people is 225 out of 1,000. Once again, we have to turn this denominator into 100, and in order to do that, we'd have to divide 1,000 by 10, because anytime you divide by 10, you take the decimal where it is and you move it once over to the left. So that's what we're going to do. We're going to divide the bottom by 10. Now, of course, we have to do the same to the top. And then down below, we will have 100, which was the whole point of that. And then dividing 225 by 10, well, similarly, all that is a matter of taking the decimal and moving it once left to the, once left, 1 unit to the left. So we're going to end up with 22.5. All right, so 22.5. And as usual, that's going to be the percentage right there. So we could say 22.5%. So do not get thrown off by the presence of the decimal in that sort of final numerator. It is possible to have percentages that feature a decimal. Okay, so looking like they want us to review some stuff over here. So let's take a look at this review. Round to the nearest tenth. Well, first of all, what is the 10th position? That would be my first question. And the 10th position, 10th with a TH right there, is this one, which means we want to round to that, which means we want to look at this spot right here, look at the number immediately to the right, and ask yourself, what does this number immediately to the right do to this number? Does it bump it up or does it leave it alone? Well, 7 is 5 or more. It's more than 5, but it's, you could say it's in the range of 5 or more. So that's going to bump this 9 up to a 10. But in turning this to a 10, that bumps this up to a 6. So this becomes 6.0. Okay. Once again, the 7 bumped the 9 up to a 10. That is the 10th position. But once this became a 10, you can't just write 10 there, right? Because that would be a 2-digit number, not a 1-digit number. So then you have to bump this one up. That's kind of an unusual one. Bumping or rounding this to the nearest 10th, well, this is the 10th position right here. And then we're going to have this number here, which is 5 or more. So we're going to bump 0 up to 1, and that literally just simply becomes 0.1. Dividing this, well, anytime you divide by 100, you take the decimal and you move it twice to the left, okay? So before I had mentioned dividing by 10. If you divide something by 10, you take a decimal and move it once to the left. If you divide by 100, you take the decimal and you move it twice to the left. So this would just become 11, okay? Now I could write 11.0, but really it's just 11. Okay, similar to before, I'm realizing there's a 34 over here. Maybe I should have done that, but let's just do these. 214.7 divided by 10. Well, similarly, we're going to move that decimal once to the left. So that's simply going to become 21.47. Okay, so now taking a look at these over here. Rounding to the nearest hundredth. Well, first of all, hundredth with a TH. First of all, the hundredth position is right here under the 2. So we're just going to look at that and we're going to ask ourselves, okay, let's look at the number that's immediately to the right. And what does that number do? Well, that is less than 5. 3 is less than 5, which means that 2 just remains as is. But then you just replace everything to the right of 2 with zeros. So this is going to be 11.12, and that's the answer. The hundredth position for this one is this 4. The number immediately to the right is 5, and that is 5 or more, which would bump up this 4 to a 5. So then you just simply rewrite the whole thing as 1000.05. Anytime you divide a number by 1,000, then you take the decimal and move it 3 to the left. So this would become 3.752. And I had already discussed before, what do you do when you divide by 100? Well, you take the decimal and you move it twice to the left. So that's going to become 18.9. Now I could say 0.90 or O, but you don't really need to write the zeros. Here, if it's a string of infinite zeros, which by the way it is, you don't have to write that because you couldn't. Okay, so we have 18.9. Now, my student at home, hopefully you realize that when I divided this number by 100, I moved the decimal twice to the left. When I divided this number by 1,000, I moved the decimal 3 times to the left. And when I've divided numbers in this video by 10, well, like this one right here, I moved the decimal place once to the left. So the thing to remember is that if you want to know how many spaces to move the decimal place, if you're dividing by 10 or 100 or 1,000 or 10,000, you count the zeros of the number that you're dividing by. So there's 1 0 in 10, which means I'm going to move the decimal once to the left. There are 3 zeros in 1,000, which means I'm going to move the decimal 3 times to the left. And there are 2 zeros in 100, which means I'm going to move the decimal 2 times to the left. So this next page is probably the most confusing one because they do throw a bunch of different rules at you that they expect you to, at some point, sort of remember, right? So let's look at each one at a time. So let's say you want to rename a percent as a decimal. In other words, they give you a percent and you have to turn it to a decimal. Well, it turns out this is actually fairly easy. You just take whatever the percent is and you move the decimal place twice to the left. So 110%, yeah, it's like that's kind of a weird percent that's greater than 100, but the principle is the same. You just move the decimal place twice to the left and then it becomes 1.1. It's also the same thing with this, believe it or not. I know they're making a distinction between greater than 100% and less than 1%, but the principle is the same. So if you have a percentage and you want to turn it into a decimal, you just take the decimal and move it twice to the left. So if we had 0.1%, well, you're going to move that decimal twice to the left. And that is exactly what they did, and it becomes this. Looking at this one, to rename a decimal as a percent, well, it's actually the opposite situation. Let's say you start with a decimal and you want to turn it into a percent. Well, you take the decimal, you move it twice to the right, and you end up with 210%. Okay, don't get thrown off by the fact that the percent is more than 100. Occasionally that can happen. Less than 1%, well, similar process. It doesn't matter. I mean, they give you some weird decimal, it's like fine, and you just move it twice to the right, and that becomes 0.2%. Okay, so just trust the process of moving the percentage over twice to the right, in this case, twice to the left in this case. Let's say you have a percent, but you want to turn that into a fraction. That's actually pretty easy. All you have to do is just take whatever that number is, stick a 100 underneath it, and then just reduce it, okay? So if they give you a percent, just put a 100 underneath it and then reduce the fraction. Now, when I say reduce the fraction, basically what I mean is, find the greatest common factor of both the denominator and the numerator and divide the denominator and the numerator by the greatest common factor. The greatest common factor of 100 and 120 is 20. So you divide 100 by 20, that gives you 5. You divide 120 by 20, that gives you 6. This is an interesting one because we have 0.2%. So the principle is the same where you just stick a 100 underneath it. So there it is. But now you have this kind of weird situation where you have a decimal over 100. Now, the thing is with this, again, we want to turn it into a fraction. It's not good form. It's not considered good form to just leave this as your answer. So you have to ask yourself, what is sort of the smallest number I could multiply zero point 0.2 by in order to turn it into a normal whole number? And it turns out that if you could just multiply zero point 0.2 times 5, well, that would actually give you 1.0, also known as 1, okay? So that's what they decided to do over here. You just multiply that numerator by 5, and of course you can't just multiply the numerator by 5 without doing it to the denominator, so they multiplied the denominator by 5, and then we have 1 over 500. All right, so if you want to go from a fraction to a percent, well, you actually take the fraction and you have to temporarily treat it like it's an actual division problem, where 3 over 2, it's like, yeah, that's 3 halves, blah, 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 blah. But really, you could think of that as 3 divided by 2. And if you want to move from a fraction to a percent, you do want to think of it that way. So you say, okay, 3 divided by 2. Well, that's 1.5. Now we have a decimal. Well, we've already discussed how to turn a decimal into a percent. From this point, you just do what we said here, where you move the decimal twice to the right and you end up with 150%. Now, here you have another fraction that we want to turn into a percent. And this happens to be a fraction that's less than 1%, which is fine. It's still the same process. You just divide the top number by the bottom number using long division and what have you. And 2 divided by 500 would turn out to be 0.004. And then you're in the same position you were here, where if you want to turn a decimal into a percent, you just move the decimal place twice to the right. That's what we did up here. So that's what you're going to do here because you have a decimal, and you want to turn it into a percent. So you move the decimal place, the decimal twice to the right, and then you end up with 0.4%. To rename a part of a fraction or a part of a percent as a fraction, divide by 100 or multiply by 1 over 100. So really you have the choice of seeing it either this way or that way, but I'm going to say stick with this way. Okay, now let's look at an example real quick. If you have 1/2%, so if the percent itself is like, a fraction or whatever, well, you just multiply it by 1 over 100, and then you're good. So you have 1 over 200. So that's how you rename a part of a percent as a fraction. So the end goal is to turn it into a fraction. So let's look at this one, 6.8. We want to turn that into a percent. Well, as I said before, that's, let's see, that is a decimal that we want to turn into a percent. So as I said before, you just take that decimal and you move it twice to the right. So that right there is going to become 680, okay, because we're going to move that twice to the right, and that puts the decimal right there, and then there's a 0 right there. So that becomes 680. So the answer there is 680%, okay? And we're just going through the motions with regards to what we learned up here. Just following the directions, that's all. 9, we're going to move that decimal place twice to the right, and that's going to become 900. So we're going to write 900%. I would advise writing the percent symbol because the teacher wants you to communicate that the final answer is indeed a percent because that's what they asked for. Now, for the same reason, this is going to become 200%. I would invite my student to check that on his own. This is going to be 333%. For the exact same reason, this is going to be 7 to 1%. Again, I can invite my student to try that at home. This one is actually going to be 0.3%. And the reason for that is because we're moving the decimal place 1, 2 to the right, and that puts it right between the 0 and the 3. So there it is. This would become, I think my student at home could probably get it, 0.7%. Let's see, this over here would become 0.21%. This right here would become 0.64%. And let's keep looking. This one would be 0.01% after moving the decimal place twice to the right. This one would become 0.05% after moving the decimal twice to the right. Let's not forget the percent symbol. This one would become 0.02%. Now, they put a 0 after this too. They didn't really need to do that, okay? Just so you know, because there's an infinite string of zeros that go on forever here. So it's kind of weird that they did that. But you want to just go through the motions of simply moving the decimal over twice to the right. That puts it here. So it's going to be 0.02. 0.02. There it is. Okay, similarly, this one would become 0.11%. Once again, we didn't really need this 0 here, so I'm not writing a 0 next to the 1 here, but I am moving the decimal place twice to the right. So that one is correct, and then we have this one, which would be, that would be 3.76 because this would move 1, 2, so the new decimal is going to be between 3 and 7. Well, there it is. Let's not forget to write the percent symbol. Okay, so that is that one. We want to turn these fractions into percentages. Okay, now they say in decimal form, but that just basically means that occasionally your final answer might be like 1.1%, where it's a percentage that features a decimal. But at the end of the day, this is just turning fractions into percentages, and that has been covered already. We covered that. That was covered here, turning a fraction into a percent. So let's do it. All you have to do is treat it like a division problem and then take things from there. So for example, 10 divided by 1 is just 10. And then once you have that 10, this is the decimal version. So you have to turn it into a decimal first, then you have to turn it into a percentage. So we are now at the second stage where we've turned it into a decimal, but now we have to turn that into a percentage. How do you turn a decimal into a percentage? Well, you move the decimal over twice to the right. So we have a 10, but we're going to move the decimal twice to the right. So that would give us 1,000. So this is actually 1,000%. So let's just be clear. You treat it like a division problem that gives you a decimal, but then to turn it from a decimal into a percentage, you take the decimal and then move it twice to the right, and then you have your percentage. This is the most complex sort of problem in that whole chart above, okay? Because it's really a two-step process. Okay, so this is going to be 7 divided by 2. Okay, we'll do some long division here. And that's really 7.0, divided by 2, and there's a decimal right there. So 2 times 3 would give us 6, which is right underneath 7. So we subtract that, and then we're going to bring that 0 down. So 2 times 5 gives us 10, and then we'd be done because it would be 10 minus 10, and that would be a remainder of 0. So we're actually done with this. That's going to be 3.5. Now we've satisfied turning it into a decimal, but we're not done yet. We have to now move the decimal place twice to the right, and then that would give us 350%. Similarly, let's look at this one. We have 6 divided by 5. Now that's really 6.0 divided by 5. We'll bring the decimal up there. 5 goes into 6 once, subtracting 5, and then bringing that down. And then 5 times 2 would give us 10. So we have a 2 right there, and that's actually it. So we have 1.2 as a decimal, but after moving the decimal place twice to the right, that would become 120%. Okay, similarly, 110 divided by 40. That's really 110.0, just in case we need that. So 40 goes into 11 no times. 40 goes into 110 twice. So we're going to have 2 right there, and that's 80. And 110 minus 80 is 30. Drop down the 0, we have 300. We still have a point right there. I'm going to do it in yellow. There's a point right there. 40 times what gives us 300? Well, that would be 7. Okay, so we're going to have a 7 right there, and that would be 280. So 300 minus 280 is 20. Now there really is another 0 here that we could drop down, so we're going to drop that down. 40 times what would give us 200? Well, that would be 5. 40 times 5 gives us 200 perfectly, and then we're just done. So 110 over 40 is really 2.75 as a decimal. But again, we want that final move where we move the decimal over twice to the right, and that becomes 275%. So that's how to do that one. 325 long division. Let's see. 325 divided by 50. Now, just in case, I'm going to do 2 zeros, just in case. So 50 goes into 32 no times. 50 goes into 325 6 times for sure. So that would give us 300. Subtracting 300 gives us 25. 50 goes into 25. Well, actually, we have to drop down the 0, don't we? Okay, 50 goes into 250 how many times? Well, that would be, let's see, 5 times, right? So that's going to be 6.5. So I had the decimal here. We're going to want to make sure the decimal's here as well, right? And here's our 5 right here. 50 times 5 gives us 250. That would result in a remainder of 0. So therefore, we're actually done with that one. And the decimal is 6.5, and we're not quite done. We have to move that decimal over twice to the right, and that would give us 650%. Okay, so this next one is the first time we have a really small number divided by this really big number, but at the end of the day, it's easy once you realize how to navigate long division with decimals. So we have 3 point, we're going to do 0, 0, 0. Now, I'm just going to use my instincts for now. We want a bunch of zeros because 400 doesn't go into 300, but it does go into 3000. So we're really temporarily treating 3.00 as 3000, as though it's 3000. Now, whenever you have decimals in the dividend, you're going to want to write the decimals up top. Now, the truth is that 400 does not go into 30, so we're going to put a 0 here. 400 does not go into 300 either, so we're going to put a 0 in that placeholder. 400 does go into 3000 though, 7 times, so we're going to put a 7 there, and that's going to be 2800. Subtracting 2800 from 3000, that's 200. truth is there's really another zero that could be brought into the picture, and then 400 times what would give us 2,000? Well, that's going to be 400 times 5 would give us 2,000, and that would be uh, perfectly 2,000. 400 times 5 is 2,000. So we're actually done, because if we did 2,000 here, we would subtract it, we would get a remainder of 0. So we're actually done here. Now the decimal, therefore, of this problem is 0.0075, and moving the decimal over twice to the right would give us 0.75%. Okay, so similarly with this one, we have 7 divided by 800. Now just to stay on the safe side, I'm going to tack on a bunch of zeros. Now, since I have a decimal here, I'm going to put a decimal here. How many times does 80 go into 70? Well, none. So there's going to be a 0 there. How many times does 80 go into 700? Well, actually, it goes in 8 times. And 80 times 8 is 640. Subtracting 640 from 700 is 60. Then we could bring this down, and that would be 600. 80 goes into 600 how many times? Well, that would be 7 times. So 80 times 7 is 560. Subtracting 560 from 600 is 40. Now we could bring another 0 here, drop it down, and we would ask ourselves 80 times what gives us 400? Well, that's 5. That would just straight up be 5. So we're actually done at that point, with that part at least. So the decimal is 0.0875. Obviously, moving the decimal place over twice to the right would give us 8.75%. So that's that one. Okay. This one, we have 1 divided by 2500. Now that's really 1 point, all this. Okay, I'm just going to write a bunch of zeros just in case. So we have a decimal there. 2500 goes into 10 how many times? 0. 2500 goes into 100 how many times? 0. 2500 goes into 1,000 how many times? 0. 2500 goes into 10,000 how many times? Well, that would be 4. And it turns out we don't really need this 0. We're done. 2500 times 0.004 would give us 1.0000. Okay? You could always verify that for yourself, but it's true. So the decimal is 0.0. You could always put a 0 here. I haven't really been doing that, at least in the long division thing, where I have been doing it in the answer. But just know there's always a 0 kind of hanging out in front of the decimal. So we have this 0.0004, and turning that into a percent means moving the decimal twice to the right, so that would become 0.04%. So that is that one. Looking at this one, we have 9 divided by 2,000. I'm going to tack on a bunch of zeros just in case. And actually, I'm going to give myself a little bit more room to work on this division problem. So it is the case that 2,000 goes into 9 0 times. So I'll just write that because, like I said last time, I should probably be writing a little 0 up here. But now we have the decimal. 2,000 goes into 90 how many times? 0. 2,000 goes into 900 how many times? 0. 2,000 goes into 9,000 how many times? Well, that would be 4, and that would give us 8,000. Subtracting 8,000 gives us 1,000. Now we can drop that down, and that's going to be 10,000. 2,000 goes into 10,000 how many times? 5. And then we're done because 2,000 times 5 is 10,000. So we are actually done, and done with that part at least. So we have 0.0045, and to turn that into a percentage, we move the decimal over twice to the right. So that's going to be 0.45%. All right. So now we have 17 divided by 3400, and that's really 17.000, just in case. Once again, I'm going to give myself some room here. And the truth is that 3400 goes into 17 0 times, so there's going to be a 0 point right there. 3400 goes into 170 0 times. 3400 goes into 1700 0 times. But 3400 goes into 17,000. How many times? Well, that turns out to be 5. Okay, so we finished the first part. We know that the answer is something like 0.005, but we have to turn that into a percentage. So we move the decimal place twice to the right. That becomes 0.5%. Okay. Now we have 41 divided by 5,000. And that's really 41.000, just in case. Just tack on a bunch of zeros. 5,000 goes into 41 0 times, so we're going to put the decimal there. 5,000 goes into 410 0 times. 5,000 goes into 4,100 0 times. 5,000 goes into 41,000 8 times. Now that would give us 40,000. Subtracting 40,000 would give us 1,000. We could always add on another 0 here and bring it down. So now we have 10,000. So how many times does 5,000 go into 10,000? 5,000 times 2 would give us 10,000. And that would give us exactly 10,000. So we're done with that part. So really, the decimal is 0.0082. Turning that into a percentage means moving the decimal twice to the right, so that would become 0.82%. Okay, so I hope that makes sense. A lot of this just has to do with just getting familiar with the rules. You could use this as a reference guide. I didn't have to because I have experience, but for my student at home, go ahead and just use this as a reference guide. If you don't know what to do, just look and see what they did up here. You know what I mean? Okay, so that's how you do this stuff. Hope that was helpful, and I will see you guys in the next video.